This lesson is on log function basics. Before we dive into the lesson, I just want to go over a couple of power rules to make sure that you're super familiar with these because we're going to use these in this lesson. I just want to talk about the difference between something like that and something like that, and something like that, and that. Okay, so 5 squared is 25. Super easy, done it forever. But I need you to remember on this next one that negative exponents do not make your answer negative, they make your answer move. So if I have 5 to the negative 2, that says square me and move me. So I'm 1 over 25. If I had 1/5 to the negative 2, again, square me, move me. So that would be a 25 on top because the 5 was on the bottom to start with. This 5 is on the top, so the 25 ends up on the bottom. This 5 is on the bottom, so the 25 ends up on the top. So that negative power just moves it. That's it. It does not make it negative. For fraction powers, remember that the top number is your power. The bottom number is your root. And again, this should all be review, but I'm just trying to make sure that it's still at the forefront of your mind. So 5 to the 1/2 is the square root, because that's a 2. So square root of 5 to the 1. If I gave you 36 to the 1/2, that's the square root of 36, which is 6. If I gave you 8 to the 2/3, again, that's the power, and that's the root. So this is the cubed root of 8 squared. Now, a lot of you are going to square the 8 first and get a 64. I'm not. I'm going to do the cube root first because it makes my number smaller. So if I cube root the 8, I get a 2, and then 2 squared is 4. If you square it first, you get the cube root of 64, and the cube root of 64 is still 4. You'll still get there, and on that one, that's not that difficult. But if you trust me, I promise, if you'll do the cube root first and then square it, your life will be much easier later. And then back to this last one, 5 to the negative 1/2. Again, the negative just moves it. It's a 5, so I know it's going to the bottom. The 1/2 is power over root, so that's just going to be the square root of 5. So if I gave you 36 to the negative 1/2, this says square root it, and this says move it, so it would be 1/6. So take a second and make sure you're good with all these examples before you move on. Okay, so we're going to talk about logarithmic functions. You should have seen these before. Most of what we do today you should have seen. We're just going to kind of take it a little step farther. So here's how you read this. This is log base A of x equals y. So like if I look at number 1, this is log base 2 of 32. Don't say log 32. Don't say log 2 32. Log base 2 of 32. This is not log times 32. It's log of 32. So to take log form and turn it into exponential form, you snail it, which you should have heard in Math 2 and Math 3. You're going to take the base, raise it to your equals, so that becomes your power. And then that's going to equal your of. There's your of over there. So if I look at this example right here, log base 2 of 8, it equals 3. Here's why. Because 2 cubed equals 8. And we call this snailing it because for some reason we think it looks like a snail. So 2 to the 3rd equals 8. Okay, so that's what I'm going to do for this whole page. You absolutely cannot type these into your calculator. I need you to know how to do these by hand. Again, you have to trust me. You will see why later. So this is log base 2 of 32. So I'm going to set that equal to x. and then I'm going to snail it. 2 to the x equals 32. So what power can I raise 2 to get a 32? Again, I'm not multiplying 2 by something. The answer is not 16. I need to raise 2 to a power to get to a 32. Well, let's see. 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. So that's to the 5th power. So this one equal to x, this is going to be 3 to the x equals 27. So 3 to the what equals 27, and that's cubed. Okay. 4 to the what equals 2. Okay, now guys, this number is getting smaller. So I'm not raising it to a whole number power. This is when you need to start to think about your roots. So how can I get from a 4 to a 2? Well, I know I can square root a 4 and get to a 2. So how can I represent the square root as a power? Well, that would be 4 to the 1/2. So my x needs to be a 1/2. And that's why you need to be super comfortable with the power over root stuff. Okay, so let's look at this one. It's a lot like number 3. 36 to the x equals 6. So 36 to the what is going to give me a 6. Again, it's getting smaller, so it's going to be some sort of root, and I know it's a square root, so x equals 1/2. And I want you to feel free to pause while you write stuff down or while you process something. Like, don't feel like you have to go as fast as the video goes. 8 to the something equals 2. Well, the square root of 8 is not going to give me a 2, but the cubed root of 8 is 2. So my x is going to equal 1/3. Okay, 144 to the what equals 12. And again, I'm setting this equal to x and I'm snailing it to set this up. And that would be the square root, so x equals 1/2. Show the snail on this one. 64 to the x equals 4. It's not square root. That's a cube root. (16) to the x equals 2. Not a square root, not a cube root, but a 4th root. 2 times 2 times 2 times 2. Yep. So that's a 4th root of 16 equals 2. Okay, now I'm going to crank it up a little bit. Let's look at this one. 10 to the x equals 1 over 100. Okay. I challenge you to pretend that you don't notice that one of these is a fraction and one of these is not. Just think about what power can get you from a 10 to 100. Well, that's a square, so I'm going to square it. That'll get me from a 10 to 100. Now, what will take that 100 and move it to the bottom? That's the negative. So please don't think that your power needs to be a fraction because you end up with a fraction. That's not true at all. I'm trying to get from a 10 to 100. That's to square it. Now I'm also moving it, so then he needs to be negative. That's what's going to make him move. So looking at number 10, get me from a 3 to a 27. That's a cube. And then he moved to the bottom, so it needs to be negative. Okay, get me from a 5 to a 25. Square it. And there's movement. So it's going to make it a negative. Now, stop this video and go try 12 through 15 on your own. Then play back the video and see if you got them right. Then pause it again and go finish 16 through 20 and see if you get them right. Play the video and then go check it. So pause the video and check one and go do 1 through 15 and then play the video to check it. Two to the something equals 32. That's going to be 5th power, and it flips, so it's going to be negative. 5 squared cubed, and move it. Okay, now this one, I'm going from a 49 to a 7. So I need to square root him. So there's that. That's going to square root the 49 and make it a 7, but the 7 goes to the bottom, so I know it needs to be negative. Okay, I'm going from a 16, not from a 16 to a 1/2. I'm just trying to go from a 16 to a 2. So that's going to be the 4th root, and it needs to be negative because it moves. Okay, pause. Now try 16 to 20, and then hit play to check them. To go from an 8 to a 2, I need to cube root it. And the 8 starts out on the bottom and ends up on the top, so it moves. So it needs to be negative. Okay, I'm going to do that one more time. The first thing I check is just how do I get from an 8 to a 2? And that's cube root. So that's what my power would be, because remember it's power over root, cube root. And then I'm going from an 8 that's on the bottom to a 2 that's on the top. That's move. So it's got to be negative. Let me do a what if. Log base 1/8 of 1/2. Okay, check this one out. Get me from an 8 to a 2. The big cube root. Now here's the question. Did anybody move? No. It started on the bottom and it stayed on the bottom. So no negative needed. So that's it. I just need to cube root it. So that negative is only when things move to the top or are on the top and move to the bottom. Let's see, I need to square root it and move it. Okay, now this one's tricky. I can't get from a 4 to an 8. Like if I square 4, I'm at a 16. If I square root of 4, I'm at a 2. I can't get from a 4 to an 8. But I can square root of 4 and get to a 2, and then cube the 2 and make it an 8. So my power, I need to square root it. That'll make it a 2. And then I take that 2 and I'm going to cube it, and that's going to make it an 8. To check it, do this. Well, this means the square root of 4 cubed. Well, the square root of 4 is 2, and 2 cubed is 8. And nobody flipped, nobody moved, so I don't need any negatives. 9 to the x equals 27. Well, I can't turn a 9 into a 27. If I square it, it becomes an 81. But I can square root it. If I square root it, that would make it a 3. And then 3 cubed will give me the 27. And nobody moved, so I don't need to change the sign. Okay. 8 to the x equals 16. I cannot turn an 8 into a 16 with a power. I can multiply by 2, but I can't do that with a power. But I can, let's see, I can't square root an 8, but I can cube root an 8. That'll make it a 2. And then how can I turn a 2 into a 16? 2 times 2 is 4 times 2 is 8 times 2 is 16, so it needs a 4. So let's check that one. 8 to the 4/3. That's the cube root of 8 to the 4th. Well, the cube root of 8 is 2, and 2 to the 4th is 4. That'd be 8, and there's your 16. This is one of those things where it either clicks and you're fantastic and like give me 1,000 of these and I can do these, or oh my gosh, I don't have a clue. Why are there some fractions? Why are there some negatives? I don't understand. If you are the second option, you need to pause right now. You need to rewind and you need to go back and just listen to all that again. This video is not going to end up being that long. You've got time. Pause it, go back, and watch 1 through 20 again without writing anything down. Just sit back and watch it and see if that helps it soak in a little bit. Okay, for some properties, think about this. If I did the exact same thing I just did, this would be 3 to the x equals 1. Guys, what power can I put on a 3 so that it's going to equal a 1? 0. Anything to the 0 power is 1. So like this one, this would be 6 to the x equals 1. So again, x would be 6. So the point is, I don't care what my base is, but if I am logging a 1, it's going to equal 0. So log base a, that just means a can be anything it wants to be. Log base a of 1 will always be 0. So stay on alert for him, because if you ever see log base something of 1, you need to know that immediately goes to 0. All right, and these are really easy. If I let him be x, 4 to the x equals 4. Well, your power obviously would need to be 1. 6 to the x equals 6. Again, your power needs to be 1. So log base a of a is 1, always. When the base and the of are the same thing, it's always a 1. Okay, the last thing we need to do is graph these. A very, very important relationship that you absolutely cannot skim over, because this is really important in the future. Exponential functions, which is the red graph, which we did 2 days ago, and logarithmic graphs, which are the green graph, are inverses of each other. Now, if you'll think back to chapter 1, we talked about inverses. And inverses reflect on the line y equals x. So if your exponential function goes through the point 0, 1, then his inverse is going to go through the point 1, 0. If your original function had a horizontal asymptote, your inverse is going to have a vertical asymptote. It's going to do this. So here's his home point, which we will shift. This is his asymptote, the pink dotted line, which we will flip over eventually. And we will shift this graph just to follow all the same rules. Okay, so let's look at number 1. Logs are growth unless they have a negative in the front of them. So look at 1 through 6 and see if you can find the one that's not growth, that's going to be decay. It has to have a negative in front of the log. And so it's number 6. So everything you see is going to be growth until you see a negative in front of the log. That's going to make it decay. So let's write that down. So log, this is growth. And this is decay. And decay is going to start tall and hit the point and come down like that. So this is your growth, and this is your decay. But they both still follow that asymptote, and they both still go through that point. Okay, so number 1 is growth, and there are no shifts. So I go through my point 1, 0, asymptote, which is a vertical line on the y-axis, draw my graph, label my point. And again, to remind you, feel free to pause this if I'm going too fast, because I know I'm talking while I'm writing, and I hope you're watching and then writing. So feel free to pause. Okay, I've got a -1 inside my function. We know from all the function we've studied that if it's inside the function, it's right, left, opposite the sign. So this is going to go right 1, and he is growth. Now, hopefully you've sort of noticed that they have different bases. For our purposes right now, I don't want you to worry about the bases. They don't influence our graphs in any way, shape, or form. Okay? So I'm going to be starting here. I'm going to go right 1, which is going to take my asymptote and scoot him right 1. And I'm growth. And I go through the point 2, 0. Number 3. That's a +2 outside the function. Now please make sure you see the difference between inside the function and outside the function. That's not log of x plus 2. That's log of x plus 2. That's outside the function. So that's up, down, true to the sign. So we are up to, and we are growth. So I will start here, and then I will go up to, which does not affect the asymptote. And I'm growth. And that would be the point 1, 2. Okay. So this one has a negative on the x inside the function. Okay, think about it. Negative inside the function. So that's going to be a twirl or a flip over the y-axis, which in this case is going to be our asymptote. Just like when we did exponentials and it was a handstand, it did over the x-axis or over the asymptote. I hope you remember from Unit 1, when it's inside the function and there's a negative on that x, I don't want you to look at that 2 and say, oh, that's a positive 2. I'm going to go left 2, because you're actually not. If you remember, I said if it's ever weird, set it equal to 0 and solve it and go true to the sign, just to help jog your memory. If we go back and look at number 2, we went right 1, because technically what you're doing is you're setting that equal to 0 and you're solving it. We're just doing that in our heads. Well, when you have a negative on your x, it affects what your x turns out to be. So better be safe than sorry. Just take that, set it equal to 0, and solve it and go true to the sign. But like when I get to number 6, because there's nothing weird about number 6, I know I'm going to go left 1. But if you think about it, you're really doing x plus 1 equals 0 and subtracting 1. So I'm going right 2, and I'm flipping, which is on this one going to be a twirl because it's inside. So I'm going to start here. I'm going to go right 2 and put my dot. The asymptote is always 1 behind that point. I am growth until I hit number 6 that has the negative in the front. And I'm flipped. Now, y'all know me. I can't flip something I can't see to start with. So here's my growth. And then I'm going to flip it. So this point is actually going to come back and be this point. And here's my twirl, or my flip over the x-axis. And then I'm going to label my point 1, 0. Now, doing these and watching me do these looks like a piece of cake, but there are a lot of different details, and what I find is that students kind of skim over this. Oh yeah, sure, I got it, absolutely. And then they get to the test, and this is one of the most missed sections on the test. But they're just graphs. So take your time, especially on your homework and when you get to this section on the test review later. Okay, number 5. That is going to go down 3 outside the function. This is not going to shift me right or left any, because if I set that equal to 0, I'm just going to get a 0. But that is going to get me a flip on the y-axis, which is a twirl. So I'm going to start here. I'm going to go down 3. Got my asymptote, always 1 behind my point. I'm growth. Sorry, forgot that. But I'm going to twirl, so I'm going to draw my dotted growth. Okay, then I'm going to take this point right here, and I'm going to flip it. So on both logs and exponentials, when we talk about flipping, you're always going to flip over the asymptote. So if you want to think handstands and twirls, that's fine, but it's always going to be over the asymptote. Okay, number 6, here we go. There he is. That's decay. I'm still going to go left 1, and I'm going to go up 1. So I'm starting here. I'm going to go left 1, up 1. Asymptote is 1 behind it. No flipping, but I am decay. Now, I just happened to run through this point. That was not on purpose. This was the point I was making sure I hit. And I didn't label points. Let's see. Let's label this guy. He would be 0, 1. And I forgot to label this guy. He'd be -1, -3. So again, if you need to stop and listen to it one more time, that's the beauty of the videos. You can watch it as many times as you need to. Okay, a couple days ago we talked about e's. Well, ln, and that's what this is, and I highly recommend a cursive L. It is not a capital L, so I highly recommend a cursive L. ln is log base e. We just don't ever write log base e. We write ln. It is a natural log. Okay, it is the inverse of e to the x. The base is e for ln's. Always. That never changes. So if we think about this ln of 1, his little base is an e. We just don't write it. So if I snail this, this would be e to the x equals 1. So x would be 0. So go back and look at the original problem. ln of 1 is 0. Now, I'm going to take a second. If you go back here and erase all this stuff I marked on, log base, I don't care, of 1 is 0. Log base, I don't care, of 1 is 0. And the rule was log base, I don't care, of 1 is 0. Well, guys, the same thing is for logs because his base is an e. And remember, we don't care what the base is, but if it's log of 1, you're going to get a 0. So that rule holds. Number 2. Remember, his base is e. So this is e to the x equals e, if I snail it. So what does your x need to be? It needs to be 1. And if you think back to that other page, we had like log base 4 of 4, that equals 1. I think there was a log base 6 of 6 equals 1. Well, ln of e, now guys, it's not as obvious because you don't have the base there. But you have to know that it's an e. Log base e of e is 1. If I set this one equal to x, and his base is an e, so e to the x equals e squared, well then x would have to be a 2. Same thing here. E to the x equals e to the 8, so my x has to be an 8. Then this one is ln of e, and that's to the star. Well, I hope you can see a pattern on number 3 and number 4. The answer here is x is just the star. The point is, if I have ln of e to the power, the answer is just the power. So some people think about it like the ln of e cancel, and the 8 falls down. The ln of e cancels, and the star falls down. The ln of e cancels, and the 2 falls down. Just one of those little things that you're going to want to watch out for. And then a couple always statements. Ln of 1 is always 0. We talked about that. Always. And then ln of e is always a 1. To graph them, they are identical to regular logs. This one's going to be right 2. So we're going to start here, and we're going to go right 2. Asymptote is 1 behind it. And I'm growth. And my point is 3, 0. Number 7. Again, this one has a negative on my x, so I'm going to be careful. This is growth. There's your decay right there. This is growth. If I go 2 minus x equals 0, I get 2 equals x. So I'm going right to, so I'm starting here, going right to, oh, that's not right. That was left. My bad. Hold on. Starting here, going right to, asymptote is 1 behind it. Okay, now there's one thing here we haven't dealt with, the fact that there's a negative on the x. That's a flip over the y-axis, or really you need to think about it as a flip over the asymptote. So we were growth. So now I flip and I come this way and I land at 1, 0. Again, I don't think this is difficult, but there are a lot of little details that you need to make sure you're okay with. What makes it growth? What makes it decay? When do I flip? When do I not? When do I need to set it equal to 0 and solve? When do I not? Last one, number 8. This one's going to go up 3. We are decay. So I'm here, up 3. Asymptote is 1 behind it. There's no flip because there's no negative on my x, but we are decay. And I would be at 1, 3. Okay, I cannot emphasize enough that you have access to this video whenever you want it. You can stop it right now and go back and watch it all again. You've got plenty of time. If there's one part on your homework that you struggle with, go back and watch that part of the video. Just, use this to your benefit.